The Fingerboardinator is a Grasshopper routine for Rhinoceros 3D that generates fretboards from user-defined parameters.
All measurements are imperial.
To use the Fingerboardinator, open Rhinoceros and click the Grasshopper button. Then open the Fingerboardinator file. The part we're interested in is over here on the left. These are the user-controllable inputs that define the fingerboard. Set the windows side by side so you can see what's going on.
The user-controllable parameters are listed on the left. They are nut width, bass and treble scale lengths. Set them to the same number for a non-fan fret fingerboard. The vertical fret setting only affects fan fret fretboards.
Set frets to 24 for maximum shred.
String spacing at the saddle. The bass and treble nut inset sliders determine the string paths. Note that scale lengths are calculated along these paths. The fret to match saddle spacing slider determines at which point the fingerboard width matches the string spacing at the saddle. This is typically the 12th or 14th fret. How long the fingerboard is after the last fret. The binding width will draw lines perpendicular to the fingerboard edges, set to 0 for no binding lines. Setting blind frets to a negative number will inset the fret slots by that amount, set to 0 for through frets.
Fingerboard thickness sets the fingerboard thickness.
The next set of inputs control the 3D construction of the fingerboard. The Fingerboardinator supports 3 kinds of radii.
Radiuses.
Radii. A uniform radius is the same along the length of the fingerboard. A side effect of using a uniform radius is a downward taper on the sides of the fingerboard. Projecting a single radius along a wedge-shaped object like a fingerboard forces the edges to taper as the wedge widens. A compound radius has set values at the nut and heel ends. The derived compound radius at heel toggle will override the fretboard radius at heel setting. Set it to true to derive the radius required to maintain a constant height at the fingerboard edge. The Fingerboardinator will also tell you the natural radius of your saddle for your scale lengths and radius settings. To render your settings as Rhino objects, you need to bake them. Note that there are 2 choices for fret lines. On the back of the fretboard as straight lines, or on the face of the fretboard matching the radii. Choose the option that works best for you. When you have the settings you want, scroll down to the Bake These group, highlight the items you wish to bake into Rhino objects, right-click on the canvas and select Bake. This sets the current state as Rhino lines and curves that can now be used to build your fingerboard.
There is also a way to bake individual components onto specific layers. First, create a new layer in your Rhino document. Then right-click on the component you want to bake, not on the canvas as before. Select Bake. Here you can select the layer to bake to, and also if you'd like to group the objects.
Do